This meeting is being recorded.
Okay, so today we'll continue with the some of the good questions, and then after that we'll again start with the theory part. Okay, so first question would be, so I gave you homework, na? Did you guys complete that?
Yes, sir.
Sir, I was not able to complete because last week I was absent in school, so I had to complete leftover work.
Okay, but you have to complete it as soon as possible, like today or tomorrow.
Yes, sir.
Right now. And Shaina, do you have any doubt in that? That was very easy questions, right? S.C. Burma.
Yeah, but sir, the 8th question part B, like the last B, and then 9th also I had a doubt.
Okay, fine. So we'll address that those doubts in the last 15 minutes of the class, right?
Yes, sir.
Or maybe after the today's class, you may be able to solve that on your own only. Because today
Okay.
I'm whatever theory I taught you in previous class, in this class today, I'll take some of the good questions. So we'll start from question number 1. See, it is saying that suppose
Okay, sir.
for the last couple of days, Wi-Fi is not that good actually here at my side. Maybe you may face some problem, but see, the question is, suppose you kick football. You kick the football, and it may follow any of the path. So I'm giving you few paths. Paths are like path number 1, path number 2.
So this is a question, right?
Yeah. Path number 3. I'll add the question as well, don't worry. Path number 4. Question says, figure shows 4 paths for a kicked football, ignoring the effect of air. Ignoring the effect of air on the flight. You have to rank the paths according to initial horizontal velocity component, comma, highest first. Means descending order. In descending order, you have to rank that. Options are 1, 2, 3, 4. Second option, 2, 3, 4, 1. Third option, 3, 4, 1, 2. Fourth option, 4, 3, 2, 1. Question says that based on the initial horizontal component of the velocity, you have to order the path. Means which path? I mean, you get by looking at the path, you get to see that the fourth path has the highest range. So now you have to relate between range and initial velocity, initial component of the velocity. So that's how you have to rate the path. Do this.
So is it based upon slope?
Not slow, based upon initial component of the velocity.
Sir, option D.
Correct. How? See, Shana. What is the value of range? R equal to U square sin is sin 2 theta upon G. So you write this as 2 U square sin theta into cos theta upon G. So take one U with sin and one U with cos. So it is like 2 times U sin theta and U cos theta upon G. So this is 2 Ux into Uy upon G. Now you can see that this range is directly proportional to Ux. The range is directly proportional to Ux. Initial horizontal component of velocity. And you can see that path number 4 has the highest range. So initial horizontal component of the velocity will be maximum in path number 4, then in 3, then in 2, then in 1. So this is the correct answer, fourth one, because highest first, right? Understood?
Yes, sir.
Note it down. I'll give you another question. Paras, it was the first question. I'll give you next question. You
Yes,
might
sir.
have studied this question on pace. Have you guys subscribed my channel, YouTube channel? Have you guys subscribed? China and Paras?
So already subscribed, sir.
I did, sir.
Oh, great, great, great. This Sunday you will have test on physics projectile motion. Done? Everyone done?
Yes, sir.
Now, second question. 4 bodies P, Q, R, and S are projected with equal velocities having angles of projection 15 degree, 30 degree, 45 degree, 60 degree. China, you may be having some unit test in your school. So you can share
Yes,
me
sir.
the date and the portion that is going to be asked in the test, so that I'll try to
So we
finish
have a test. We have a test on Saturday, this Saturday.
on this Saturday. That is too close, na?
But sir, our next exam is the term exams, and we have a lot of portions for that. It's past
Yeah,
most
so
2D.
you can share me the syllabus. IUC has also shared, but IUC has a lot work power energy. We cannot finish that.
Oh yeah, we have it too, sir. We have post that.
Okay, you can share me the topic so that I'll plan things accordingly.
Okay.
the body having shortest range is option P, Q, R, D, S. Four bodies P, Q, R, and S are projected with equal velocities having angles of projection 15 degree, 30 degree, 45 degree, 60 degree with the horizontal respectively. The body having shortest range is.
Sir, P?
Yes, correct. Let them follow you.
So P.
Yes. Let's China solve as well.
So I have a question. So isn't it in directly proportional to sine theta cos theta?
Yes, yes, definitely, yes. It
So
is.
so wouldn't P be the highest?
See, what is the range? The range is the U squared sine 2 theta upon G. G is constant, gone. U is same in every case with equal velocity. Means U is same. So range is directly proportional to sine 2 theta. And now you can see that this is the angle. No? So you can see. I don't want to go into the trigonometry right now, but I can see 2 theta. So theta is 15 degree and 30 degree and like that. So one would be sine 30, sine 60, sine 90, and sine 120. So sine 30 is half, sine 60 root 3 by 2, sine 1, sine 91, sine 20, sine 120 is similar to same as sine 60, that is root 3 by 2. So which one is the shortest? This
Yeah,
one. Na?
got it. So this is what I was doing, but I think I was trying
You've
to,
broken into two things, na? Sine theta and cos theta.
yeah.
So whenever you want to find maximum value or minimum value in trigonometry, so always try to reduce the term. You cannot find maximum and minimum when you have two different terms. If you have one term, you can find easily. Done? Let's move ahead. Third question. This is the third question. See, this is the question. Paras, can you enable your video? Yes.
So if air resistance is there, then it will apply force to that. That's when. Is that point B correct?
Which one?
B means option A.
Option A. Yes.
Yes, sir. I think I got the same thing.
We got the same.
Yeah.
Because of air resistance, height and range both will decrease. Understood? Na? I see you also understood.
Sir, I didn't understand this.
Because of air resistance, na, height and range both will reduce. because when there is no air resistance, so you can use G only. But if there is some air resistance, so when ball will go up, there will be air resistance downward. So it will stop. It will try to stop ball reaching to the highest level. Right now, I see.
Yes, sir.
That's why.
So actually, I was having doubt. Air resistance will be from right to left and from upward to bottom. Will it be from bottom to upward?
No, air resistance means what? What do you mean by friction? Friction is something that will oppose the relative motion, right?
Yeah.
So it will always oppose your direction of motion, whether you go from right to left or left to right or top to bottom or bottom to top. If you are going top to bottom, down to up, it will up act up to down in reverse direction always.
Okay. And if the air is in the same direction of which we have thrown the ball, then
That
it
is
will
different
increase
thing.
the range.
That is different concept that I'll discuss in the class. Don't worry.
Okay, sir.
Tell me one thing. Do you guys have a school on Saturday? IC and China.
Yes, sir.
Till what time?
I have it until 12.
And what about after that? You're free?
Yes, sir. I think so. It
Actually,
depends.
chemistry sir wants to take class on Saturday and Sunday.
Oh, okay. So I'm
So
not sure. I think I'll be free.
okay, so I'll maybe like I'll ask the timings. Then I'll communicate accordingly. Maybe around 3 or 4 He will take class. Are you comfortable now?
Sir, I didn't hear it. So what were you saying?
So chemistry sir wants to take class on Saturday and Sunday this week actually because of his busy schedule. So are you free at around 3 p.m. or 4 p.m. something like that in the evening?
Yes, sir.
Okay, I'll communicate by maybe by tomorrow or. So are you? Do you think that you will do this question?
Yes, sir. 2 minutes.
Yeah, sir, 1 minute.
Sir, option A. The
Which one, Faraz?
option A.
Ah, right. This is the option. This is the correct option. You can also remember this observation. This is good observation. China and Ayushi, done or not? Or still?
Sir, can you please tell this?
Yeah, I'm telling you. See, first thing you know that suppose you are throwing some object at certain angle theta, stone projected with velocity u at an angle theta with horizontal reaches maximum height h1. So in this case, the maximum height is h1. In second case, it is being projected at 90 minus theta at complementary angle. So in both the cases, range will be same, right? At complementary angles, I told you, range will be same. Again, with the same velocity, same initial velocity u. In this case, it reaches some other height, maximum height h2. So you can apply the formula of maximum height. What is that? h1 equal to u square sine square theta upon 2g, and h2 would be u square sine square theta. But in this case, theta is 90 minus theta because this is the angle of projection. You can see here, this h2 will become u square cos square theta upon 2g. And you have to relate, right? You have to relate. So you found h1 as u square h1 is u square sine square theta upon 2g, and h2 as u square cos square theta upon 2g. And what is the value of range? That will remain same in both the cases. You can take any u square sine 2 theta upon g. You can break this. How? Or see. Just multiply these two things. Equation number 1, equation number 2. Multiply this. 1 multiplied by 2. You will get h1 into h2 u4 sine theta into cos theta whole square upon 4g square, right? Now you can see sine theta into cos theta whole square will be cross multiply this 4 times g square h1 into h2 upon u raised to 4. Just multiply and divide by 2 and 1 by 4. So that it will become sine 2 theta. So this sine 2 theta whole square will be 16 times g square h1 h2 upon u4. Now you can find sine 2 theta over here, from here. Sine 2 theta is square root of that 16 g square h1 h2 upon u raised to 4. Put here u square by g. Sine 2 theta is 4 will come out, g will come out under root h1 h2, and u square will come out. This gone, this gone. So this is 4 under root h1 into H2. Right?
Okay, sir.
So you can remember this observation.
So is there any other method? Because here we have to check all the options. Uh, that's why.
No. No. Why do you want to check all the options? You already got option number 1, na?
Yes, sir. But if we don't know, then we have to check whether if
No, why
I
are you
first
going by?
checked it.
No, no, no. Don't go by options. Just go by the process.
Okay, sir.
So where is the working for after the cross multiplication? In blue. Sir, on mute.
Okay. From where?
The blue color part. I can't see
See.
it in a photograph again.
Okay. Blue color part you can't see. See, you have noted down till here. Till here. That yellow part, na?
Yeah.
Okay. In a blue part, let me write. This is 2. I just multiplied by 2 and balanced by 1 by 4. So that this 4 and this 4 will get balanced. So now this will become sine 2 theta whole square equal to, this is 16 g square h1 h2 upon u raised to 4, like this. Okay, from next question, like I'll write in sequence.
1/4.
Understood, Shaira?
So is that 1/4? What?
Yeah, this is 1 by 4. This is 1 by 4.
Okay. Yes, sir. Done.
Done, everyone? Ayushi and Paras?
Yes, sir.
Yes, sir.
See, next question. Oh, it's too large. This one. I guess you guys are not getting, right? See, I am solving it. See, solution. See, question says a stone is projected from the ground with a velocity 50 meter per second at an angle 30 degrees. Okay, fine. I'll draw a rough diagram. This is X and this is Y. This stone is projected at 50 meter per second at some angle 30 degree with the horizontal. See, it crosses a wall after 3 seconds. See, it crosses a wall after 3 seconds. Suppose it will definitely follow the parabolic path. Suppose here there is a wall. Suppose here anywhere this is the wall. Suppose this is the wall. And it says that it crosses the wall after 3 seconds. So from here to here, it has taken 3 seconds, right? Yes. How far beyond the wall the stone will strike the ground? Means what would be this distance? First of all, do one thing. Find time of flight. Time of
5
flight would
seconds.
be how much?
5 seconds.
5 seconds. Yes, correct. 2 into 50 into sine 30, that is half upon 10. Gone, gone, gone. That is 5 seconds.
Oh,
Sorry?
so I think I was using the wrong formula for time of flight. Like I was using the formula for projectile from a height.
Okay.
But sir, okay, you can continue. I think.
Okay. Shall I continue?
Yes, sir. I was just
Okay. So what I have done is now we have found out the total time of flight. That is 5 seconds. And now it is saying that in this projectile takes 3 seconds to reach, to cross wall. It means that after crossing this wall, for the further 2 seconds, this wall will move. Correct? And now you have to find displacement along x-axis. So, you know, as per Galileo, motion along two mutually perpendicular direction is independent to each other, right? So now we have to find this displacement, and we know that in projectile, if there is no air resistance, there is no external force, the horizontal component of the velocity of the projectile always remains constant. And what is the horizontal component of the velocity? This 50 cos theta. So that is 25 root 3. So here as well, it will have different vertical velocity, but we'll have same horizontal component. So time we have, and this horizontal component we have. So we can find this distance as 25 root 3 velocity into time. That is 50 root 3. Tell me, you understood or not?
Yes, sir.
Everyone understood or not? So
Yes,
after
sir.
it took 3 seconds to cross the wall. So after, and total time of flight is 5 seconds. So after crossing the wall, it will travel for the next 2 more seconds. So you have to find the horizontal distance for the next 2 seconds. So time you have, and you just need horizontal component of the velocity. That is constant always in projectile motion. So just multiply it there.
Sir, can we find it using range?
Using,
Range.
yeah, you can find, nah, you can simply, okay, you can find range, and like, you can find the distance between the point of projection till wall, right? And you can subtract that thing from range. You can do, no problem in that.
Oh, why did you multiply it into time?
Distance table is what? Speed into time, na?
We have okay. Yeah.
And we have horizontal component, na? That is always constant in projectile motion. That's why.
Okay. Got it.
Now, another good question.
So
Let
just
me know
1
when.
minute.
Okay.
Done, sir.
Next question. This is a very good question. This is comprehension type. So this is the comprehension part, and on this, based on this comprehension, you have 3 different questions. So
The first question, answer A, option A.
sorry, what is your answer?
First question's answer, option A.
No, 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 no. No, sir. Read the passage carefully. Acceleration is not same throughout the motion.
So will the angle change? Will theta change? Because if we split up the graph into 2.
See, looking from no, angle will not change. See what it is saying. Let me read this. A stone is projected from level ground with a speed u at an angle theta with the horizontal. Okay. Let me draw this. At some angle, a stone is projected. Okay, fine. It is saying that somehow the acceleration due to gravity g becomes double. That is 2g. Immediately after stone reaches the maximum height, means it will follow parabolic path. It is saying that when this stone will reach the maximum height, this height at this point, so till this point, acceleration due to gravity would be beta g only. But as soon as this stone reaches the maximum height, this acceleration by somehow will increase, will be double, right? So from here and thereafter. So thereafter acceleration changes. Now you cannot say that time of flight is 2u sin theta by g, because acceleration is not uniform throughout the motion, right? Now you can see that time of ascent and time of descent till maximum point, this time we can call it time of ascent, and this point we can call it time of descent. So time of ascent, we know the formula u sin theta upon g, and time of descent, we know the formula u sin theta upon 2g, right? No, this is not correct. This if you do this now, and if you add, you'll get answer A. That is not correct actually. This is not correct. See, what we will do is you'll feel the difference. See, time of ascent we know, that is u sin theta upon g. Okay, fine. We also know h max, we also know H max, that is U square sin square theta upon G, because from here to here acceleration is G. Now you have to find the time taken by this particle, this stone, to come down. See, so this particle is now coming from here to here. So this is the maximum point. So maximum point, at maximum point, this particle will have only horizontal velocity, no vertical velocity. So here there is no vertical velocity. What it will have only horizontal component of the velocity. Now it is like the vertical displacement is minus h. So apply this. S equal to ut plus half g t square. So s is minus h, u is 0, because now here the initial component of vertical component of the velocity is 0. So this is 0 plus half. And always this acceleration always acts towards downward. So now this g is not actually g. This is 2g and that is downward. So minus 2g. Suppose I am taking upward positive, downward negative, or into t square, that is td square. Now this 2 gone. So minus h equal to minus g into td square. So this td square is h upon g. So this td is what? Under root h by g. Now you can see, and you can also relate this ta to h. How? See, from here to here, while going, again the displacement would be plus h upward equal to ut. U means some. Oh, let it be like this one. Okay, now you have to find h. So h is what? Maximum height that you can use from here to here. So put here u square sin square theta upon g into this g. So it will be u sin theta upon g. U sin theta upon g. Right.
Sir, I didn't understand this step.
Wait. So you understood till here, right? Right now.
Yes, sir.
Now we have to find time taken by the stone to come from this highest point to the ground. So we have used this thing. Now I'll put the value of h here. H is how much? Oh, h is 2, na? H squared sin square theta upon 2g, na? So this
So
h is,
two will like get cancelled out, right?
that, no. See, what is the formula of h max? H square sin square theta upon 2g. So whatever will be the height here, the same height it will come with double acceleration. So definitely it will take less time, na? So I'll put this h here, u square sin square theta upon 2g and into this g. So this is u sin theta upon g will come out 1 by root 2. So time of flight is t ascent plus t descent. T ascent is u sin theta upon g. We have the same thing over here as well. So take common, you can take it as common. Then 1 plus 1 by root 2. So the answer is B. Understood? If you have any doubt, ask me.
So in H, why you took 2G?
Sorry?
You have written the H equals to u square sin square theta by 2G.
This is
Then
the
why not
formula
G?
of maximum. In projectile motion, this is the formula of maximum height. U square sin square theta upon 2g.
Yes, sir, but can't we write G there, because first with G on G velocity only, it's going to H max.
Right. Okay. So with acceleration g, it came to maximum height. Now this maximum
Yes.
height will remain constant. Now, after reaching to the maximum height, now it will attain double acceleration. So it will come down same height. Na? This height is not going to be changed. Na?
Yes.
Yeah. So height will remain same.
And
So it will
and
just
sir,
tell.
and sir,
Tell me.
S equals to ut plus half gt square.
Yes.
There, so you have written ut as 0.
UT
But
is 0
in
because
the
Because at this point, at the maximum point, you know that the stone will have only horizontal component. At maximum point, there is no vertical component. Otherwise, it would have gone further, like, up, right? At a maximum point,
Yes.
the vertical component of the velocity is 0, na?
So we can, yes.
So I am just, like, applying this formula along vertical direction.
Means that is SY or what? In the
SY,
Y
yes, it
direction.
is SY, yeah. So displacement along Y
Okay.
direction.
Okay.
Let me write this as SY. SY, UY, GY.
You have one mindset, it is just a displacement. It is never negative.
Sorry?
You have written minus H. That not in this. Why minus?
This one?
Yes.
Yes, because we have taken upside as positive, downside as negative. So downside, displacement is vector quantity. You have to take with sign, na?
Yes. So but it is constant. H is constant there.
H is constant, but you have to give sign, na? Because this is displacement. And you are
Okay, sir.
coming down. That is why I have taken minus 2g. Acceleration is
Okay,
also
sir.
downward. So we have to give proper sign. No?
Yes, yes. Actually, I was having a doubt in last lectures in one of the problem.
What, Paras?
In last lecture, you took one of the question. In that, I was having a doubt.
Which question?
That a small body.
What small body? In
Uh,
last
it,
class? In last video?
yes, yes.
I'll take it later. I'll take it later.
Okay, sir. Okay, sir.
So noted, na guys? Noted? China and Ayushi, noted?
Yes, sir.
I'm just doing the next question, sir.
Okay, great, great. Paras, you also done, na?
Yes.
Now, solve this question, 15th one. Why it is taking time? You know the time of flight is what? Just now we calculated u sin theta upon g, 1 plus 1 by root 2. Now you have to find range, na beta. Range is what?
Yes.
Initial. Yes, tell me.
You just have to add the first range and the second range.
No, why to do that much work? Just na, range is what? Initial horizontal component into total time of flight. So you have, u cos theta, you have this thing, just multiply this. You will get u square sin theta into cos theta upon g 1 plus 1 by root 2, multiply and divide by 2. You will get u square 2 sin theta cos theta. That will give you sin 2 theta upon 2g 1 plus 1 by root 2. Here is your answer. Yeah, this is your answer. Range is what? Simple, na? U cos theta into total time of flight, right? And 16th question I will solve. So first you note it down. I will solve 16th question. Noted. Done.
1 second.
Yes, sir.
Okay. Ayushi done now?
Yes, sir.
Okay. Now I'll do 16th question. See. This is like you have projected with u at some angle theta. It will follow parabolic path. After reaching maximum height, it will have acceleration 2g. Okay, fine. Now it is saying that the angle phi with which the velocity vector of the stone makes with horizontal just before hitting the ground is, see, just before hitting the ground, like this, it will hit here, like this, it will hit. So now it is saying that how much, so phi is the angle that it makes with the horizontal. So this angle is phi, just before hitting the ground. After hitting the ground, I don't know. It will depend back, right? But just hitting, just before the before hitting the ground, it will be like this. So it will make some angle with the horizontal. Now you can see that. We know that in projectile motion, horizontal component always remains constant. So suppose here velocity is v, speed is v. So it will have two components, vx and vy. And this is the initial component, u sin theta, u cos theta. You know that there is no external force in horizontal direction. So velocity will remain constant always. That is why vx must be equal to u cos theta, initial horizontal component. So vx must be u cos theta. Now we have to find vy. How to find vy? See, you have projected from here and the ball hit the ground over here. So what is the displacement along vertical direction? Zero, nothing. There is no displacement along vertical direction. From here, ground to ground, there is no displacement along vertical direction along y axis, isn't it? So I'll apply this formula. Sy equal to, not Sy, Vy, V square equal to U square plus 2 A square into V square equal to U square plus 2AS, right? V square equal to U square plus 2AS. This is this formula. Now you can see you cannot apply this formula from here to here because acceleration changes. From here to maximum point, acceleration is g, but from maximum point to ground. Acceleration is 2g. So this is not uniform. And acceleration, if acceleration is not uniform, you cannot apply this formula. So better you apply from this point, from A to from B. A to B, you have to apply this because in this journey, acceleration is constant. And you know that at this point, this is the maximum point. So only it will have horizontal component, that is u cos theta, and there is no vertical component, 0. So again, from this point to this point, we can apply this formula. So here, the initial component is 0. So 0 square plus 2. And acceleration is 2g, but that is downward. So minus 2g. And what is the displacement? That is minus h. H max, right? From year to year. Understood? China.
Yes, sir.
So minus minus plus 2 into 2, 4. 4gh. H you have already found. That is u square. From year to year, we have already found u square sin square theta upon 2g. So this gone, this. So Vy is under root 2 u sine theta. Now you have to find this phi, this angle. You know that vector addition. This is how we find. This is Vx, this is Vy. So this tan phi would be, suppose this is your Vx, this is your Vy, and you have to find this V with horizontal phi. So this is the vector addition. So this is Vy. So this is also Vy. So tan phi is perpendicular upon base Vy upon Vx, and Vy is under root 2 u sin theta, and Vx is u cos theta. U gone. So this is root 2 tan theta. So tan phi is root 2 tan theta. Understood? Or not? It was a good question, right? Noted.
Done, sir.
Done, sir.
Done, Paras?
Yes, sir.
Next question. Do this.
So, option C.
Correct.
Mm.
Good, Shana. Correct. Paras and Ayushi. Are you guys done with question number 7?
No, sir.
Why, sir? Why no? Simple, na? It says that two particles are projected from same point with same speed at different angles. Suppose this particle is projected at same speed, so you at different angle. This particle is projected at same speed, but angle is different with the horizontal. They have the same range. So R1 must be equal to R2. Now you know that R1 is what to be whatever U square sine 2 theta 1 upon G. Same range means U square sine 2 theta 2 upon G. If they have same range, so theta 1 must be equal to theta 2. Na? If they have same range, so you can see U square by G is same. So sine 2 theta is sine 2 theta 1 must be equal to sine 2 theta 2. So theta 1 must be equal to theta 2. Their time of flights are T1 and T2. No, take 1 minute. Two particles are projected from same point with the same speed at different angles with the horizontal. They have the same range. If they have same range, now you can see one thing.
They're
One thing you can see. They may be complementary angle. Right? They may be complementary angle. You know that if at two different angles with same velocity, if range comes out to be same, it means that both the angles are complementary to each other. So theta 2 must be equal to 90 plus theta 1, isn't it? Understood? So time of flight is 2u sine theta 1 upon g. T2 is 2u sine theta 2 upon g. T1 by T2 you have to find, just divide it. 2u by g, 2u by g gone. So this is T1 by T2 sine theta 1 upon sine. For theta 2 put 90 plus theta 1, that is tan theta 1.
Sir, theta 2 should be 90 minus theta 1, right?
No, it's the same thing. So it's 90 minus theta 2.
Both are complementary to each other. No? That is fine. No?
Okay.
Even if you put, yeah, that is you're correct. It's the 90 minus theta. My bad. It's my bad. So again, same thing you'll get. No? 90 minus theta cos theta. No? Shaina, how did you get? You did the same thing that I did?
Yes, sir. Pretty much.
Good, very good. Very good. Done?
Yes, sir.
Yes, sir.
Next question. Do this.
So I'm getting 2 into GH, 2 into root GH by 3.
So answer is what?
I, I, I don't think it's there in the options, but like,
Okay. How did you solve?
so
Can
we
you
know,
explain?
so if we just take H as height, we know H equals U square sine square by G. So sine square theta is sine square of 60. So sine 60 squared, and that's 3 by 4. So U square into 3 by 4 by G equals H. So H into G into 4 by 3, whole root of that. So 4 you can remove 2 into root GH by 3.
Okay, do one thing. See, a stone is projected at an angle of 60 degree from the ground level, strikes at the angle of 30 degree here. Here, at on the roof, it strikes at 30 degree. Speed of projection. Suppose the speed of projection is u. Suppose. Now you know that in projection, at every point, the horizontal component of velocity remains constant. You know. So initially it was u cos 60, and here you can see this is the velocity, and this is the 30 degree. So if you draw a line kind of axis, so if this thing is 30, so this is again 30, opposite vertical angle. Fair? Yeah, so suppose this is V. So V cos 30 and V sin 30. You know that horizontal component will always remain constant. So V cos 30 must be equal to V cos 60. Sorry, U cos 60, initial one. So V into root 3 by 2 equal to U into 1 by 2. So V is U by root 3. This is the relation, right? Okay. Now you have to find U. Okay. So U, and you have to use H as well. Okay, fine. How would you use H? You can see here, it has two, it has this component. So this is V by 2, and V is what? U by root 3. So this is root 3 into 2. So this is the Vx, and this is Vy, right? So from this point
So
to this point, yeah,
I didn't,
tell me.
so I didn't understand what you just did.
You did not understand?
No. So
Which
what
one?
were you? V by 2 equals U by 2 root 3.
This part.
No, not that one. Near the height. Yeah, for finding height. Yeah.
See now, at this point, this particle will have some velocity, right? So you break this into two components, along x and along y. So along x, it is Vx, that is V cos, V cos 30, and this thing would be V sin 30. So this is vertical component, and we found the relation between U and V from here. We can use this, put V equal to U by root 3 and upon this 2. So V by U by 2 root 3. Understood?
Yes, sir.
Now, apply this formula. V square equal to U square plus 2AS, but all will be along y-axis. So this. So V square is how much? So this is the V square, that is minus, this is downward, minus U upon 2 root 3 whole square equal to Uy. This was, the Uy was, this was the initial component, Uy, that is U sine 60, that is root 3 U by 2 whole square plus 2 AY, that is minus G, and displacement is upward, that is plus H. You can see here, this will be U square upon 12. This is 3 upon 4 U square, and this is minus 2G H. You have to solve this, you will get answer. How? See. 2GH will come this side, this will go this side. So 3 by 4 U square minus U square upon 12. That is LCM 12, 9 U square minus U square. That is 8 U square upon 12. So this 2 and 8 will cancel. 4 and this 3 will cancel. So GH equal to U square upon 3. So U square is 3GH. So U equal to under root 3GH. Understood? This is the answer. Understood, guys?
Yes, sir.
Note it down.
Done, sir.
Yes, sir. Done.
One last but very good question. See, question says a stone is projected from a horizontal plane. It attains maximum height h and strikes a stationary smooth wall and falls on ground vertically below the maximum height. Assuming the collision to be elastic. इसका मतलब its meaning is if collision is elastic, it means that like it will have the same speed or velocity before striking and after striking, right? To be elastic means energy will be conserved.
So does the stone hit the wall in when it's at max height?
So yeah, no. It is saying that it will fall just vertically below the maximum height. So definitely it will have to hit the wall after attaining the maximum in second half. After
Oh.
attaining the maximum height,
It rebounds.
it will rebound. It will rebound. I'll draw the picture. Wait. So uh, so find the height of the point on the wall where ball will strike is. See, I am drawing the diagram. See, it is saying that suppose this is the ground and from here you have projected a ball, anything ball. It will follow the path. It has suppose attained the maximum height over here. And wall has to be here, somewhere here. Otherwise, it cannot attain the maximum height. Na? So after attaining the maximum height, it strikes the wall. Somewhere here, it will strike. And now it is saying that the ball will fall on the ground just vertically down the maximum height here. It will fall somewhere here. Understood? Just vertically below the maximum height. Now you have to find this height. You have to find this height where this ball will strike the wall. This is a very good question. Very nice concept. Try for a few minutes.
That collision to be elastic means
Yes, suppose any ball, suppose like this is striking to the wall. China and I, you also understand. Suppose at this point, before striking the wall, it has some velocity. So it will have two components, Vx and along this wall, Vy. So if this is elastic, it means that it will rebound back. So it will rebound with the same horizontal velocity, Vx. And in vertical direction, there won't be any change. So this will just reverse and Vy will remain as it is. Understood? This is the meaning of. So horizontal component will not change if the collision is elastic. And vertical is nothing going to happen with the vertical component. Now solve it. What happened, guys? Not yet done? Did you understand the scenario? Let me no. Let me explain you. Let me explain you. Let me explain. See, think. Suppose if this wall was not here. Suppose if this wall was not here, then this will follow this. This must have followed this complete path, and this is the range, right? Like this. So this is the maximum point. Suppose. So whatever time it will take from here to here, it will take same time from here to here, right? Correct? Okay. Now, because this is elastic collision, so at this point, if it was like at this point, initially it had it 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 will strike like this. So it will have this velocity. So it will have some in its horizontal component and some vertical component. But this collision is elastic, right? So it will reverse. It will rebound with the same horizontal velocity. It means that so from here to here, whatever distance it it will cover the same distance. It will cover from here to here. So by symmetry, we can say that. But because this particular same horizontal velocity, so this distance and this distance must be same, right? Right? Because collision is elastic. So whatever distance it was supposed to travel, if there was no wall, then so even after so that is why after striking the wall, it will cover the same distance. So by symmetry, this distance and this distance must be same. Understood or not? Because this will have same horizontal velocity. Now, initially, it had this velocity component, horizontal component Vx, and because of the collision is elastic, so it will reverse with the same horizontal component, horizontal velocity. So it will travel either way, same distance. So this distance and this distance will be same. It means that the time taken by the particle to travel this distance or this distance must be same. Suppose this is t, so this must also be t. Now you can think this particle is coming from here to here, right? So what is the horizontal displacement for this particle? Same, this distance, that is x. And when this particle is coming from here to here, again this particle will have same horizontal distance. So in both the cases, this case and this case, in both the cases, this particle will have same horizontal distance. And here as well, here, if this is u and this is angle theta, so this horizontal component is u cos theta and vertical component is u sin theta. So here there is no, at maximum height, there is no vertical component of the velocity. It will only have horizontal component that is equal to u cos theta. And here as well, when it will strike the wall, it will have the same horizontal component of the velocity. Because in projectile, if there is no external force working, at every point of the path, horizontal component will remain constant. So this x, it will travel with this horizontal component, that is u cos theta into t1. Suppose it takes t1 time, and here to here it will take some, again u cos theta, same horizontal component, u cos theta into t2. So velocity is same in both the cases, distance is same in both the cases, so time taken must be same. Understood or not? It means that time taken by the particle to come from here to here is t as well, and time taken by particle to come from here to here is t as well. You got this point, why time taken from here to here and here to here will be same? Did you understand that?
Yes, sir.
Ayushi,
Yes, sir.
Bharat? Okay, now see, now this is the maximum height. You know that this time is t and this time is t. So time of ascent is 2t. So definitely time of this. So time of descent is 2t. So definitely time of ascent will also be 2t. because there is no external work. We are neglecting the air friction, right? Now you can calculate very easily. Okay. From year to year, you can apply from year to year in during the ascent. During ascent, you can see time taken is this much. Okay. So I will not go this way. I will not go this way. Rather, I will come in reverse direction. Suppose this is the maximum height. I will come from here to here. It will reduce your calculation. See, at this maximum height, there is no vertical component of velocity. There will be only horizontal component. So we'll write the equation of displacement along vertical direction. How? Displacement along y equal to uy into t plus half ay into t square. Suppose if you take upward as positive, downward as negative, so you are covering this h displacement along y direction. So this is negative y direction. So this is minus h equal to. At this point, there is no initial velocity. So uy is 0. So 0 plus half ay is always downward, that is minus z into time is how much? 2t. How much time it has taken? 2t. 2t whole square. So this minus gone. You can see that h equal to half g into 4t square to 2. So t square is h upon 2g. First you note it down. T square equal to h upon 2g. Let me know if you have any doubt. There can be many other ways. There are actually, but this is the best way to solve this problem. Otherwise, like in 4-5 lines.
So can you do it by just equating the ranges? Because you know there are two parabolas, right?
Yes, you can do that. By equating the range, you can do that, but that will, I think, go long. That will take some steps to calculate.
Oh, okay.
Because you have to find range this way, that way, you have to add this and like that. That will be little lengthier, and this is the best way. This is the completely very good, nice concept.
Yes, sir.
Done, sir.
Yes, sir. Done.
Paras, you are also done. So I can see that t square is h by g. T square is h by 2g. Now we have to find this height, na h na. For this height, what I'll do is, see, for this height, what I'll do is, I'll write the equation from this point to this point, because this height we know h and this height is small h. So what would be this height? This would be how much?
H minus.
Capital H minus h, right? Now I have to find, we know that in this journey, it has taken t time. So I'll apply Sy equal to Uy into t plus half Ay into t square. Sy, displacement is this much, na? This much, that is minus, displacement is downward, so minus h, that is initial component of velocity. Sorry, initial velocity will be here, and it has no component vertically. So this will be 0 plus half g is minus g into time taken is small t. That's it. It's done now. So this is minus h plus h equal to minus half g into t square. So h equal to, h will go that side, minus half g, and t square is how much? H by 2g. H by 2g. G gone. So this is h minus h by 4, and your answer is 3h by 4. This is very good concept. You guys understood completely now?
Sir, H minus H, I didn't understand.
This will go this side, na? This capital minus h will go this side, na? Okay, this thing you did not understand. See,
No, sir.
maximum height. This is the maximum height, and this height where it where the ball strikes the wall is small h. So this gap is h minus h, na? Total height minus this height.
Okay, okay. Yes, sir.
Note it down.
Sir, in chemistry, where is sir going to start from?
Chemistry, sir.
Yeah.
I will start with atomic structure.
Oh, okay.
Sir, done.
Done. So today is like complete class took like it took like complete whole class. So from next class we'll start with equation of trajectory. You can note this equation of trajectory. Equation of trajectory. And I also forgot to take the take Saina's doubt. So Saina, in next class I'll take your doubt first, then we'll proceed with the theoretical part.
Okay, sir.
Let's meet tomorrow at 5.
Yes, sir. Thank you.
Bye.
Thank you, sir. Bye, sir.
Bye.